Welcome to AI Podcast. I'm David, and with me is Maya. Today we're turning an EMNLP 2023 paper into an easy listen. It's called Revisiting Automated Topic Model Evaluation with Large Language Models, led by Dominik Stammbach with colleagues at ETH Zurich and the University of Maryland.
Hi, David. I'm ready. Give me the short version first.
Here's the TLDR. Large language models can judge how coherent a topic's top words are better than the common automatic metrics. On the classic word intrusion game, they perform about the same as humans overall, but don't line up with human judgments any better than the old metrics. And when you want to choose how many topics a model should have, a practical trick is to ask an LLM to label the top documents for each topic and pick the model whose topics have the purest, most consistent labels. That choice tends to agree with standard clustering measures.
Okay, so LLMs are both careful reviewers and helpful assistants for picking the number of topics. Who's behind the work again?
The study is led by Dominik Stammbach from ETH Zurich, working with co-authors there and at the University of Maryland. It's a collaboration between NLP researchers and a social science-oriented team, which helps ground the evaluation in real use cases.
Got it. Before we dig in, remind me why evaluating topic models is tricky in the first place.
Topic models summarize big text collections as themes, each shown by a short list of top words. Two long-standing headaches are, first, how to automatically judge whether those word lists actually make sense to humans, and second, how to pick the number of topics, the parameter we call K. Popular scores like NPMI and CV are fast, but often don't match human preferences. Human evaluation is closer to the truth, but slow and expensive. And choosing K is often a manual, hard-to-reproduce process.
So the gap is reliable, scalable evaluation without hiring a crowd every time?
Exactly. The authors ask whether a general-purpose LLM can stand in for human raters and whether it can also help select a reasonable K that's aligned with the analyst's goal.
What did they try first?
They start with two standard human tasks. One is a rating task, where you see the top words of a topic and give a coherent score. The other is word intrusion, where you spot the one word that doesn't belong. They prompt ChatGPT to do both, mirroring the instructions humans receive, and compare the model's judgments to existing human annotations across 2 corpora and 3 topic modeling algorithms, covering about 300 topics.
Nice. So how did the LLM do?
On the rating task, very well. Its scores track human judgments more closely than the usual automated metrics and get close to the ceiling set by human-to-human agreement. On the intrusion task, accuracy is about the same as human raters overall, but topic by topic, the model's choices don't correlate better with human preferences than the classical metrics. They also checked variations. A minimal prompt still worked. An open model, Flan T5XL, showed the same pattern but weaker correlations than ChatGPT.
That makes sense. The rating task feels more like what we do when we read a word list and decide if it expresses a clear theme.
Right. The intrusion game hinges on a single choice, and different cues can lead to similar overall accuracy without matching human patterns per topic. Now, the second contribution tackles K, the number of topics. The key idea is to stop judging only word lists and look at the top documents for each topic.
Walk me through that.
For each candidate model, they take the top 10 documents per topic, show the opening snippet of each document to an LLM, and ask it to assign a concise label. Then they compute how pure each topic is, meaning what fraction of those documents share the same label, and average that purity across topics. The model with the highest average purity is preferred. Crucially, the prompt encodes the research goal. If the analyst wants broad categories, the labels are broad. If the analyst wants fine-grained categories, the labels are narrow.
So instead of asking if the words look coherent, we're asking whether the documents grouped under a topic actually describe the same thing. That feels closer to how people use topic models.
Exactly. They test this on bill summaries and on Wikipedia, considering both broad and specific categories, and compare against a standard ground truth clustering measure. The document label purity lines up well with that ground truth. By contrast, picking K based on average word list ratings doesn't align. If the goal is meaningful document groupings, evaluate the documents.
Did they sanity check the snippet approach? Using only the opening text could be risky.
They did. For Wikipedia, the opening sentences usually define the article. For the bills, they manually checked that the main topic appears at the start. They also showed that looking at the top 10 documents per topic gives almost the same signal as using all documents, which keeps the procedure efficient without losing much fidelity. And in a manual spot check, the vast majority of assigned labels made sense given the requested granularity.
Good to know. Now the caveats.
First, the main results rely on ChatGPT, a closed model, which raises reproducibility and cost questions. They did try an open alternative, but it trailed in performance. Second, an optimal number of topics depends on your goal. The purity method is aimed at content analysis, where you want semantically clean clusters. If you care about diversity or retrieval, you may want a different objective. Third, prompts can inject priors. Specifying broad or narrow categories is realistic, but it does steer the labels. And finally, short snippets may be insufficient in domains where key information appears later.
That's fair. There's also the general concern that any LLM-based evaluator is a bit of a black box.
Yes, the authors mitigate that by providing code and describing prompts, but dependence on a proprietary service remains a consideration for teams adopting the method.
Let me summarize. If I need a quick, human-like sense of whether a topic's top words hang together, I can ask an LLM to rate them and expect a better match to human judgments than with standard metrics. But to choose the number of topics, I shouldn't rely on those word-level ratings. I should evaluate the top documents per topic, get the LLM to assign labels that match my research goal, compute label purity, and pick the K that looks best.
That captures it. A few forward-looking ideas are worth considering too. Replicate with strong, open models to avoid vendor lock-in. Extend to multilingual and noisy domains. Combine purity with diversity or coverage to balance clean clusters with breadth. And consider longer or multiple snippets when intros are weak. Packaging all of this into a small, logged workflow would also help reproducibility.
That would make adoption easier. If someone remembers only one sentence, what should it be?
Evaluate what you actually care about. If your goal is coherent document groupings, have the LLM look at documents, not just word lists, and let your research question guide the prompt.
Clear and calm advice. Thanks, David.
And thank you, Maya. This has been AI Podcast. If you found this useful, share it with a colleague who works with topic models. Until next time.